Okay, students, let's look at this question here, which was taken from the year 2008 paper on question 10. I believe this was taken from one of the NJC tutorial on sequence and series. Question 7. Let's say I can do this proficiently. So Joe puts $10 on 1st January of 2025 into a bank account which pays compound interest at the rate of 2% per month on the last day of each month. He puts a further $10 into the account on the first day of each subsequent month. Okay, so essentially every month there will be you will add a 2%, meaning you will compound 2%, then you add another 10, then subsequently you just add another 10 as 2% as well, then just keep on recurring. So this would have some form of like recurrence relations. Okay, so how much compound interest has the original $10 earned in the end of 2 years? So remember, initially Joe plays $10. Okay, so at the end of the month, end of first month, he will have 10 multiplied by 1.02. This original $10, just this original $10, not accounting for the subsequent $10. So the end of second month, you also multiply by 1.02. Okay, so end of second month, you have $10 of 1.02 to about 2. So essentially, you have 2 years. The total amount will be $10 multiplied by 1.02 to the power of 24, because you have 24 months in 2 years, right? Here, then what you do is you key in calculator, you get $16, 16.08. Okay, so now you need the compound interest earned. So the compound interest, the interest will just be you minus off the principal. The principal is just the $10, the original $10 that you have. So it's $16.08 minus off $10. All right, great. Let's look at part 2. Essentially now, let A and N denote the total amount at the end of n months. Find the value of A1 and the recurrence relation in the form of AN plus 1. AN plus, okay, we need to find A1 later, the adder of A1, right? So remember, in recurrence relation, if you want to understand, if you have AN and AN plus 1, if this is the current term, okay, essentially AN plus 1 is the next term. Okay, so or rather, if this is the current term, then this will be the previous term. Okay, the idea is there's a recurrence, there's a relation between the two terms. It could be two immediate neighbors, or it could be the two immediate neighbors, or like a few doors away. Okay, it doesn't have to be totally immediate. So we need to find the value of A1. We just follow the first month. It was $10, right? End of first month will just be grand total of n of month. It will be $10 multiplied by 1.02. There will be 10.2. Okay, this is our A1. End of first month. So just right now, A1 is $10.30. Okay, then just recurring. So basically, the next month will be you can follow the what Joe was doing. Basically, he add $10, right? So subsequently, this is A1 plus $10. You can write the entire thing here, but we don't want to write this. We just write A1. But then after which, what we have is same thing. We multiply by 1.02 here. The entire thing will be 1.02 multiplied by A1 plus 10. Okay, that will be good. So this is about A2. Okay, this is A2 recurrence relation. So you follow the trail of money here. You add another $10 and multiply by another 2% at the end of the month. That will be A2 plus 10. Then this will be 1.02 multiplied by A2 plus 10. Then this will be about A3. Okay, so you follow down the case here. You look carefully. So hence, AN will AN, okay, essentially you want AN plus 1. You need AN plus 1 in the function of AN. Okay, great. So if this is AN plus 1, so you expect, if this is AN plus 1, this will be this will be N, right? So okay, you can write this out. You can write this as, if this is N, then this will be N minus 1, right? Okay. Then this case will be AN minus 1 plus 10. Okay, but because they want AN plus 1, you can just write AN plus 1. You replace N with N plus 1, or you can just deduce straight, also can. So AN plus 10. Okay, so this is the function that they want you to deduce. Let's look at the last part, which is part 3. With the aid of a graphing calculator, determine the total amount in the account in the end of 2 years. Okay, great. So this just use table value, then you're just going to deduce the amount. Okay, so the recurrence relation now is this guy here. Now remember, the first term is $10 and $10.20 because this is the recurrence relation end of the month. The first term is $10.20. Okay, not $10. Okay, just remember that. So I'm going to bring up my GC here. Just go to mode and then just put in so just go to mode, right? Just mode, press mode, then you just go to recurrence relation here, sequence, then quit, then you go to this guy here. Now this is n+1. Okay, so I could just use we could just use sequence. We just put the n+1 here, not an issue. Okay, then so this will be 1.02 an. So an is u. This is u n+1. So this is u. Instead of a, you put as u. So u is this blue guy here. Then you just put n bracket. Then I'll put a +10 here. Okay, your first term will be 10.2. Just put 10.2 there. Okay, then you go to table value. Then you just start. Okay, 10.2, 20, and so the first month, first month, second, and third month. So they want you to go to 24, right? What we need to do is just scroll it down to 24 because this is end of first month, end of second month, and so on. Then we're just going to scroll down to 24. That this is the answer here from GC. We know that this will be 310.30 cents. So that's the answer. Subsequently, the number of complete months for the total of the account to first exceed 2,000. So you need to be complete months, right? So obviously we just scroll down to the term there which has more than $2,000. So I'm going to scroll it down. Just scroll. Okay. If it takes very long, what we could do, okay, instead of just slowly scrolling through, remember, you can just put plus. You just increase the table value by 10. So this will just increase by, you see this increase 43, 53, 63. So we need this to be 2,000, right? Alright, yeah, so this will be here, around here, 83 here. Then we can put plus. Don't forget to what do you call it, micro, like basically change the table change to delta to 1. Okay, so fine tune it. Don't forget to fine tune it. That's what I'm trying to say. So this case, we need the complete months to be above 2,000. Would be n equals to 81 months. Okay, so that's that. The number of complete months will be 81 months. So that's how I do this question here proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.